In this particular problem, we are given few conditions. So here this expression, and we are also given the fact that x, y, and z are positive, with x not equals to 1, y not equals to 1, and z also not equals to 1. So using this condition, we need to find the value of x raised to the power of x times y raised to the power of x times z raised to the power of z. So let's begin. So we will start with our given condition. So here we are given the log of x divided by y minus z. That's equals to log of y divided by z minus x. And this is equals to log of z divided by x minus y. So we'll suppose that let all these three expressions be also equals to lambda. Now that means we'll start with the first expression, log of x divided by y minus z equals to lambda. And cross multiplying, we get log of x equals to lambda times y minus z. Now what we'll do, we'll multiply both sides with x. That gives us x times log of x equals to lambda times x multiplied to y minus z. Now x log x can be also written as log of x raised to the power of x. So here we have used a fact that if we have a times log of b, so that's equals to log of b raised to the power of a. Right. This gives us lambda times, so let's distribute x with y minus z. So this gives us xy minus zx. Now we'll use the second condition, log of y divided by z minus x. So let this be equals to lambda. So this will imply the log of y will cross multiply to get lambda times z minus x. We'll multiply each side with y, which gives us y times log of y equals to lambda times y multiplied to z minus x, which will be equals to log of, using the same property, log of y raised to the power of y equals to lambda times, we'll multiply y with z minus x, so we have yz minus xy. Then we'll take the third condition, log of z divided by x minus y, this is equals to lambda, which will be log of z equals to lambda times x minus y, which implies, now we'll multiply both sides with z, so we have z log z, that's equals to lambda times z multiplied to x minus y, which gives log of z raised to the power of z, which is equals to lambda times, so here we have z times x minus y times z. Now what we'll do, we will add all these three expressions. So adding them was going to give us log of x raised to the power of x plus log of y raised to the power of y plus log of z raised to the power of z. Now adding the right hand side, we'll see that each of the terms in the right hand side has lambda as the common factor. So we'll have lambda multiplied to xy minus zx from this particular expression. Then from this expression we have yz minus xy plus the third expression gives us zx minus yz. Now for the expression on the left hand side, we can combine them as log of x raised to the power of x times y raised to the power of y times z raised to the power of z. So here we have used the property of logarithm. That means if we have log of a added to log of b, then this is the same as log of a times b. Right. Continuing, on the right hand side we have lambda times, so here few of the terms gets cancelled out. Actually it's all the terms that will get cancelled out, xy minus xy, negative zx, positive zx, yz, and negative yz. So this will leave us with lambda times 0. So that means we have log of x raised to the power of x times y raised to the power of y times z raised to the power of z equals to 0. Now we will use the definition of logarithm. That means if we have log of a with the base of b, and if this value is equals to c, then this means that a will be equals to b raised to the power of c. Now in our case, we do not have the base of the logarithm provided here, but whenever the base is not provided, it's by default considered to be equals to 10. So that means we can use our property to get x raised to the power of x times y raised to the power of y times z raised to the power of z. So that will be equals to 10 raised to the power of 0. Now we know anything raised to the power of 0 gives us a value of 1. So that means our final value, x raised to the power of x times y raised to the power of y times z raised to the power of z. So that value is equals to 1.